All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone.
Morning, sir.
Morning.
How are you today?
Alhamdulillah.
Alhamdulillah.
Very good.
And you?
All right, guys. Okay. So before we start our lesson, let's pray. Pray begin. Pray finish. All right. Okay. By the way, actually, we finished already the topic yesterday. Yeah, we cover all the topic. So today we have only 1 hour. In the second hour, I'm going to give you assignment like last week. There will be a video and virtual lab. We're going to see the lab, and then you're going to make a report as usual. So in the first hour here, 1 hour, we're going to solve some question. Okay, before I will solve the question, first I'm going to ask you, do you have any question that you cannot solve?
I have a question, sir.
Yes, please.
About the post-test yesterday.
Post-test?
Yes.
All right, let's see the post-test. I haven't checked the result yet. I'm sorry, guys, because this week a little bit very busy. We have accreditation. There are something that I have to prepare for accreditation, and also we have also final tests. So we have to prepare also for final tests. So I haven't got any time to check. All right, let me check the result. I'm sorry, where is it? All right, here. Wait a little bit. My connection is not stable if I turn on my camera. All right, now it's coming. All right. This is 11A. Come on, come on, come on. It's very slow, yeah. I couldn't open. Right. Now it's opening. All right. Most of you got 10. Very nice. But Ryan, you have problem, I think. Okay, but most of you are did. Very good, thank you. Okay, let's see the question. Yes, Ryan, what's the problem? This is number 1. Question number 1. How we can solve this one? Let me wait a minute. Can you see my screen now?
Yes, sir.
Yes, sir.
Let's do how we solve the first question. The reaction is given. The conventional equilibrium constant expression Kc for the system as described by the above equation is, so it is just writing the Kc, isn't it? So we know that this is the reaction. Okay, why the color is like this? This is the reaction. So you just write the Kc. Kc is equal to concentration of product, isn't it? So SO2 to the power of square, because we have 2 here, time concentration of O2 and divided by concentration of SO3 square. Isn't it? If I check this option, so the answer will be B. Is it true? Hello guys, is it true?
Yes, sir. Yes, sir.
Very simple, yeah? It's just writing the expression here now. Anyone have problem with this? No? Okay. Very good. Okay, now question number 2. This is question number 2. All right. Can you see the question?
Yes.
Yes, sir.
The reversible reaction to SO2 plus O2 to SO3 has come to equilibrium in a vessel of specific volume at a given temperature. Before the reaction begins, the concentration of the reactant were 0.06 mole per liter of SO2 and 0.05 mole per liter of O2. After equilibrium is reached, the concentration of SO3 is 0.04 mole per liter. The equilibrium concentration of O2 is, okay, this is also just you are using ice, I think. You're going to write the reaction to SO2 plus O2 and 2SO3, and we are going using ice. Okay, in this question, we are not giving the mole, but we are giving the concentration. No problem, guys. Sometimes in the ice, we can use also the molarity. Yeah, because they are in one vessel, so the volume is the same. So here, for example, before the reaction begin, it means its initial concentration of the reactant were 0.6 and 0.5. So here is 0.06, but it's smaller, yeah. The unit is smaller. 0.05 here, and no SO3 because it is in the product. And then after the equilibrium is reached, the concentration of SO3 is 0.04. It means here 0.04 after the equilibrium is reached. So what does it mean? This is minus, minus, this is plus here. So it must be here 0.04, isn't it? Because when you sum I and C, you will get E. The E is 0.04, I is 0, so C must be 0.04. It's C 0.04 here, here must be 0.0. Look at the ratio. 0.0. Sorry?
Sorry, sir. We can see your screen.
Oh, why don't you say yeah? Tadi nomor 1 juga nggak bisa lihat berarti?
Iya, sir.
Why don't you say?
Saya kira memang gitu tadi, sir.
Alright. Okay, here. Okay, I repeat again, we are going to write the reaction here. And we are using ice. Okay, initially 0.06, 0.06, and 0.05, 0.05. Okay, and then we got 0 for the product, and then in the C, minus, minus, plus, and because the equilibrium is 0.04, so the changing for the SO3 must be 0.04. So if it is 0.04 here, in oxygen, it must be 0.02,
Two.
right? It must be 2 here. And here 0.04, isn't it? Because the same, yes. So this is when you sum 0.02 here, 0.03 here, and 0.04 here. So the question is the equilibrium concentration of O2, it must be here, 0.03, so the answer must be C. Very simple question, isn't it? Okay. Okay, Ryan,
Yes, sir.
any other question? Any?
I have center, but in Zambak book,
Okay, which number?
multiple choice number 16 and 23.
Okay, let's see the Jambak book. Let me open first. Wait a minute. I have to open first the Zambak book. Which number?
16, sir, and 23.
16 and 23. 16. Let's see number 16. And this one. Can you see?
Yes, sir.
Okay, let me do like this so we can. Sorry. All right. Can you see now? The value of the equilibrium constant of the given reaction is 2.5. If at given temperature, the mixture of 0.6 mol PCl3, 0.4 mol of Cl2, and 1.2 mol of PCl5 are at equilibrium, what is the volume of the container? It's very simple, I think. Anyone can do? You can do like this, Eric. I don't know whether there is a trick or not in this question. Let's do. It seems to be very simple. Kc will be equal to concentration of PCl5 time or over concentration of PCl3 times concentration of Cl2, isn't it? And we are asking the volume, yeah? We don't know the volume. PCl5 is 1.2 mol over the volume, let's say V, I don't know the V, over PCl3 is 0.6 over the volume also. And what else? Cl2, 1.2 mol, isn't it? Sorry, Cl2 is 0.4, 0.4 over V, yeah? And it must be equal to, what is the value here?
2.5.
2.5. Okay, V is cancelled, one of the V. So 1 over 2 over at time V over 0.4 times 0.6 times 0.4, 0.24, isn't it? Equal to 2.5. So 1.2 V is equal to 2.5 times 0.24. V is 2.5 times 0.24 divided by 1.3 or 1.2. Okay, let's do 2.5 times 2.4 times 10 to the power minus 1, isn't it? Over 1.2. This is cancelled. It is 2. So it is 5 times 10 to the power minus 1, which is 0.5 liter. So the answer is A. Okay, Eric?
I have a question, sir.
Yes.
But in the question, this PCl3 is solid, sir. Why we include them in Kc?
Oh, no. There's something wrong here. PCl3, it cannot be solid. Must be gas. Typo, maybe. If you put it solid, you will not get the answer, isn't it?
Yes, sir.
Yeah. So it's typo maybe in the books. All right. What is the other number?
23.
23. Okay. Let's see who can solve. Everyone try to solve. Okay, you can write your answer if you can find it in the chat column. Any answer? No? Okay, let's solve together. Equal moles of H2 and Cl2 are placed in a 1 liter container, and the system reach equilibrium by using 3 mole of hydrogen, 3 mole of chlorine. When the system is at equilibrium, the total number of moles of gases is found to be 10. Okay, what is the Kz value? All right, here we are going to write the ice, H2 plus Cl2, 2HCl, ice, equal moles of H2 and Cl2. We don't know, yeah, but we know that it is equal at the beginning. Yeah, initially H2 and Cl2 is equal, but we don't know how many mole. Let's say that it is A mole here and A mole here, because it is equal. Yeah, and in the product, we don't have product at the beginning. Changing, the system reach equilibrium by using 3 mole of H2. Here is using 3 mole, so minus 3 here, and Cl2 also 3 mole. Yeah, so minus 3 also here. In here, plus 6. Is it true? Plus 6? Hello, guys. Do you understand how to get plus 6?
Yes, sir.
Yeah. The coefficient, yeah, 1, 1, 2, so 3, 3, 6. So after this, we got the A minus 3 here, A minus 3 here, and 6 here, the mole. And it is given that the total number of mole at equilibrium is 10. So the total of here is 10. So A minus 3 plus A minus 3 plus 6 equal to 10. Okay, so we got 2A minus 3 plus 6 is cancel, is equal to 10. So A is equal to 5. When you put A equal to 5, you got 2 mole here, 2 mole here, and 6 here. and the volume is 1 liter, so the mole will be also the molarity, and the Kc will be equal to, it's very simple now, Kc will be equal to concentration of HCl square over concentration of H2 times concentration of Cl2 equal to 6 square over 2 times 2. So it is 36 over 4. It is 9. So the answer is E. All right. Is it clear? Very good. Any other question?
I have question, sir.
Yes, please.
Zambak, in number 2, what's the meaning of homogeneous equilibrium?
Okay. I didn't explain this, yeah, because in Indonesia, generally they are not included here, but it is very easy to know this one. Homogeneous mean what? Homogen, isn't it? Homogen means what? They are the same type. I mean the what we call that one, the state of the equilibrium must be the same. If gas, all of them gas. If aqueous, all of them are aqueous. That's homogen. If there is something different in the state, then it is heterogen. So which question, Abdi?
Number 2, sir.
Number 2, multiple choice.
Yes.
All right. Okay. Okay, let me share the question. Number 2, multiple choice. Which of the following is homogeneous? Just you will see that which one is the same. So the answer must be this D, isn't it? How I can write in here? There's no pen. Okay, so the answer for this one is D. Here is the answer. Any other question? Yes, guys, come on.
13, sir.
Yes,
13.
13. All right. Very good question now. 13 is the graph question, isn't it? This. All right, let me do like this. Very good question, this. Right. What may be the equilibrium constant expression for homogeneous gas reaction with small number time relationship is given in the graph? It is small number times, isn't it? So from here we have 4 substance, X, Y, Z, T. We have 4 substance, X, Y, Z, and 3, and T. X, Y, Z, and T. My question is, which one reactant, which one product?
Y and X are reactant.
X and Y are reactant, isn't it? X and Y are reactant. Z and T is the product. Because reactant is always decreasing, as you can see, product is increasing. Yeah? True? True.
Yes, sir.
Now,
Yes,
you
sir.
are given here the mole number, so you can use ice. Ice. Initially, X and Y is 10. As you can see here, initially X and Y at 10. Z and T automatically is 0. At equilibrium, this point is equilibrium because it's already constant. Y become equilibrium 8. Y become 8 here. X become 6. Z become 4. T become 2. Yeah. So from here, I can understand that this is 4 here, 2 here, isn't it? Here, Y
-2.
minus 2, X minus 4, isn't it? So I can understand that X, Y, Z, T, the coefficient will be 4, 2, 4, 2. So it is the ratio 2, 1, 2, 1, isn't it? Or 4, 2, 4, 2. It can be also. So from here, I can understand that Kc can be like this. Kc will be equal to Z square times T, sorry, Z square times T over X square times Y. Do you have this option?
D.
D.
Yes, this E. So like this. Okay,
I have questions, sir.
this.
I don't really understand why we got the coefficient to X, Y, to
Now,
Z, and
okay, I understood your question. The changing is made according to the coefficient, isn't it? When we are using ice, the ratio of changing will be the ratio of coefficient. Is it true? Guys?
yeah,
Yes, right? So the ratio is what? The ratio is 4, 2, 4, 2. So this Kc can be, the question is maybe, guys, maybe, kemungkinan. Which one? It is not the real Kc. The possibility here. Kc for this reaction can be also like this. Kc can be also Z to the power of 4, T to the power of 2 over X to the power of 4 and Y to the power of 2. It also one possibility for this reaction, the Kc. But there is no answer like that. So we have many possibilities actually for this reaction. It depends on the coefficient here, because when we see the ratio 4, 2 can be or 2, 1, 2, 1. Apalagi yang bisa? Many things. 6, 3. 6, 3 also possible. Okay? But the only choice that here is this.
D, sir.
Yes?
Why the answer is not D? Because the concentration X.
Oh, sorry. Yeah. Sorry, wrong. D. It must be D. Not Y square, yeah? X square, yeah? Right. It's not C, sorry. D. Okay? All right, we have only 2 minutes now. Okay, let's stop here. Okay, in the second hour, I'm going to give you the link as usual, and you're going to watch the video, and then you will make the report of your virtual lab. Okay, it is explained there. Please watch carefully the video. It's very interesting video because you're going to see the reaction with the different color. Okay. Do you have any other question?
Assalamualaikum, Sir. Izin, Sir.
Ya.
Bisakah kami share screen video buat Hari Guru, Sir?
Buat siapa?
Buat Pian, Sir. Hari Guru, Sir.
Okay. But it's only 1 minute.
Mungkin lewat GC kelas atau di sini aja, Sir.
Okay, you can share to the WhatsApp.
Oke, Sir.
Okay.
Udah kirim ke GC kelas. Makasih, Sir.
Thank you very much for today. Very meaningful celebration for you. We are very proud of you. Thank you very much. See you again next. I think we finish this semester. We are going to see you in the final test. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Sir.
Welcome.